Hey guys, Mr. Middleton here. Today we're going to talk about law of sines. At the end of this video, you should be able to determine when law of sines is appropriate to use, and you should be able to use law of sines to find missing angle measures and side lengths. Okay. If we look at this triangle, and if we're trying to find the missing side lengths or angle measures, notice that we are not able to use trig to solve this problem. And the reason is it's not a right triangle. Our trig ratios that we've talked about only work for right triangles. The law of sines that we'll talk about today will allow us to find all the missing pieces of this triangle. And it works for any triangle, not just right triangles. And the law of sines is a ratio. It basically says that A over sine A in any triangle is going to be the same as B over sine B and C over sine C. Okay. Notice that the side lengths are shown using lowercase letters, and angles are shown using capital letters. Or uppercase, I don't know who calls it uppercase. Okay. So when we say A, this is angle A, this would be side A. This is angle B, this would be side B. This would be angle C, this would be side C. Okay, now I'm going to show you a proof. Now, you will not have to know or make this proof again, but knowing a proof does help you to understanding why something works helps you strengthen your ability to use it. Okay, so more than just saying, hey, this works, I don't know why, just do it. I want to show you why we know that it works. Okay, so in order to do that, we're going to drop a line here, perpendicular to the base from the vertex there. I'm going to call this H. Okay, we could use it now that we've had. We're doing that so we can have a right triangle. Okay, and now that we have that right triangle, we would be able to set up an equation to solve for what H is. Okay, so this is just a random triangle, but in this triangle, I could find H, say that sine A equals H over B, which would be our opposite over our hypotenuse. Okay. In this right triangle, I could say the same thing and say that sine B equals our opposite H over A. Okay, and I'm going to solve for H now. In this triangle, I'm going to do that by multiplying by B, and so I get H equals B sine A. In this triangle, I'm going to do that by multiplying by A, and so here I get H equals A sine B. Okay, and so since we're talking about the same H, I can actually write that B sine A equals A sine B. Okay. I'm going to divide both sides by sine A. Sine A. And so on this side it cancels out. We get B equals A sine B over sine A. Okay. And then finally, I'm going to multiply both sides by, I want to get rid of sine B. It would be really weird for me to divide by sine B, so I'm going to multiply both sides by 1 over sine B. That's the same as dividing by sine B. Okay, and so it cancels out here. And so what I'm left with on my right side would be A over sine A. And what I'll be left with on my left side is B over sine B, which is the relationship that our law of sines tells us is true. Okay, we'd have to do the same thing with sine C, but we could. This is just an explanation that this is why it works. We chose a random triangle. Okay, there's nothing that has to be specific about this triangle, and we're able to show that this relationship was true. So it's going to be true in any triangle. Okay? Alright, so got that. We are going to now look at using the law of sines in order to find missing angle and side lengths in triangles. So here it says use the law of sines to find the indicated side lengths and angle measures. Excuse me. Find the length of C to the nearest hundredth. So C, this side, to the nearest hundredth. What we will need is a completed angle and side. Okay, and so we need an angle that has its opposite side measured as well. In this triangle, we have angle A, which is 77, and the side opposite, we'll call it side A, which is 15. And that's enough information for us to be able to find anything in this triangle. So we can say A over sine A equals C over sine C. And since we're given those measures, then we can say, instead of A, we can say 15 over sine 77 equals C, which we still don't know, over sine 23. We want to solve for C. The thing that's stopping C from being by itself is sine 23, so I'll multiply both sides by sine 23. Okay, so on the right side it cancels out. On the left side we'd have 15 times sine 23 over sine 77. Okay, biggest thing that happens with people on problems like this is they try to put too much in the calculator at once, and it goes bad for them. So let's be careful of what we put in. I'm going to put the numerator in, 15 sine 23 equals, and then I'm going to divide by the denominator, sine 77 equals, okay, and we find that C is, to the nearest hundredth, 6.02. Okay, so there's our setup and our solve. Number 2 says find the missing angle measure to the nearest tenth of a degree. So we're trying to find this x. I'll label these sides A, B, C. So this is A, this is B, this is C. So we're trying to find angle B. We need to use side B. We have angle A and side A, so it's enough for us to use this. So we'll say 11 over sine 50 equals 7 over sine of x. So I want to get sine x by itself, and on top I'm going to start by multiplying both things by sine x. The reason I'm doing that is so I can get it on top. So I get 11 sine x over sine 50 equals 7. I actually could, that's what I could do something else, but I'm not. Yes, I will, because you guys will want to do that. This is for you guys. Alright, so we're going to have to do a lot more math to get this out of the bottom. Remember when we talked about our proportions in our first chapter that if we said that, 4 over 8 equals 1 over 2, then we could know that 8 over 4 was going to equal 2 over 1. And so that's what I'm going to do here. Even though our ratios are set where the side length is on top and the angle measure is on the bottom, I'm going to try to find the angle measure. So I'm just going to flip this and say sine of 50 over 11 equals sine of x over 7. And that'll save me a few steps. And so now I can multiply both sides by 7. And so I'll have 7 sine of 50 over 11 equals sine x. Okay, so as we do that, I'm going to simplify that left side. 7 sine 50 divided by 11, and it gives me this big number. So I'll get sine x equals that big number, okay? Let's write 7 sine 50 over 11. Now, oops. Okay, now, please do not abbreviate, round this number, and then enter it for your answer. Okay, you need to use all these numbers and all the memory that your calculator has that it's not displaying for your final answer. Because we get sine x equals this number. In order to find our variable, we need to now use inverse sine. And so what I'm going to do to get rid of sine is I'm going to do x equals the inverse sine of all this. Okay, I've already entered that into my calculator. Now I'm going to just go inverse sine, second answer. Okay, so I can get the most accurate answer that I can. And I find that x is 29.2, because it says to the nearest tenth of a degree. 29.2 degrees. Okay. Number 3, it says in triangle FGH, and I want to make sure that I draw it out. FGH. FH is 7, HG is 12. The measure of angle F is 72 degrees. Find each of the remaining angle measures and side lengths. Give angle measures to the nearest degree and side lengths to the nearest hundredth. Okay, so here we go. Where do we start? Well, I think it'd be easiest to start to find G. And the reason that we start to find angle G is because we have side G. And so we can say sine 72 over 12 equals sine G over 7. Okay, and so sine G equals 7 times sine 72 over 12. Okay, and so what we'll do now is we will need to figure that number out. 7 sine 72 over 12. Okay, and we need to do the inverse sine in order to get G all the way by itself. So inverse sine, second answer. And that gives us 33.69, says to the nearest degree, and so we can find that angle G equals 34 degrees. Okay, so we found that this is 34 degrees. Alright, that should make finding angle H easier because it's a triangle. So 34 plus 72 is 106. 180 minus 106 gives us 74 degrees. Okay. Now that we have 74 degrees, find that third missing side and bring that to class completed. Okay. So just leaving 1/3 of that side for you. Okay. Still have to use your law of sines. Make sure you show your proportion. Be careful with your calculations, and be smart with your roundings. All right, see ya.